Welcome to Learning Target 2. This is uniform probability distributions and expected value. Uniforms are actually a little bit easier to deal with than just like what we call the simple ones. The simple ones don't really have a pattern, but the uniform ones work kind of nicely. This is our new theme for the unit. I hope you enjoy it. It's a safe theme. It's just one of the Google PowerPoint or Google presentations themes, so it's a standard safe theme versus the last unit. Okay. So what we're going to try to do is play deal or no deal. We're going to try to predict the offer that he gives us. And so we're just going to kind of walk through this on this website here. So you can actually play this game on your own. It's a nice little break. And so I'm just going to walk through how to play this. So I don't know if you know the rule of the games. Like, you just have to select however many briefcases they tell you. So we select one to start. So I'll select number 18, lucky number. And so they tell us to take 6 cases to be removed, and each time they're going to give us a number, and so they're going to remove those, and so those are definitely not like your case. And so if $1 million comes up, $1 million go off the board, and you can see what happens. And so we got 15. This is $5,000. I'll select 10. It's $200,000. It's a big prize. Select 1. And 10. So that looks actually pretty good. We're going to take one more. $50,000. Okay. And so what happens is this guy gives us a call and he gives us an offer. And so depending on what's left, he's gonna make us offer $16,000. Rather than predict the deal because it just comes up so fast, what I want you to do is determine whether or not this is a good deal or not. And so it is unfortunate that these kind of get blocked off, but perhaps like with the snipping tool we can kind of see what those are the next time. So it's $16,000 right now. Like, what is that based off of, and is that a good deal? And so we're going to say no deal right now. And so just while we have that right now, what we're going to do is just kind of like take a little snip of, this is how you use a snipping tool, of this side so that it's not blocked off next time. Okay. So we select 5 cases to be removed. We're going to take off 8. Take off 25. That's not good. Take off 11. That's definitely not good. And take off 24. And one more. Lucky 13. That's not good. So his deal's probably going to be less than it was before, we'd assume. So he's making us an offer of $26,000. So before he offers 16. So I want to see, like, again, you can pause the video to find out if that was a good deal. And I'm just going to set these guys up here so you can see what these were. And so just to line them up, we've got the 1,000, 10,000, 25,000. We've got the 100,000, the 400,000, and the $750,000 prize left. I'm going to say no deal. $400. Oh, that's bad. 17. That's really good. And it's $25. Okay. So I'm going to kind of give away how you calculate this, and so looking at this, I'm going to actually want to see if this is a good deal. I'm just going to bring out my calculator, and all we're going to do is we're basically just going to take the average of what's left, and that's going to be your probability or your expected value. And so if we take 1,000 plus 10,000 plus 25,000, plus, I think the 25,000's left, 75's gone, 100's gone, sorry, 75's gone, but 100's still there. We've got the $400,000 prize left. So we can add 100,000 plus the 400,000 plus the 500 plus the 200 plus the 75 and 50 and 5 and 1. And we count those up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Divide that by 11. And we should actually like have $48,000. That's what we expect to get. I'm going to say no deal. 3 cases to be removed. $1. $25,000. And I'm going to do this now. So 5 plus 50 plus 75 plus 200 plus 500 plus 1,000 plus 10,000 plus another 500,000. And I'll subtract off the one that I don't get. And there's going to be 1, 2, 3, 4, 5, 6, 7, 8 cases left after I take one more away. So subtract off the $50. And divide that by 8. And he better be offering us 64,000. We're definitely not going to take that deal. 2 more. That's not good. $200. Try that again. 110. The 1. That's 111,000. Plus, oh, he's only giving us 18 grand now. 500 plus 75 plus 5. And there are 6 cases left. He's giving us basically what we should get right now. So I'm gonna make the deal. What's in our case? $1,000. We made a good deal. You guys can play this again. You can do the calculation on your own. I was doing it purely based on calculation. I probably should have taken 52,000. Okay. Let's go back to day 2. Let's close this guy. Okay, so your learning target. I know that a uniform distribution occurs when in a single trial. Let's get rid of this. Single trial, all outcomes are equally likely. I can represent the distribution in a bar graph and table and calculate expected values in the table. That's actually really just from the simple one. It's just with the uniform. The big thing is all outcomes are equally likely. We just saw with the deal or no deal, each case was equally likely to come up. So the expected value is very straightforward to calculate. We just add them up and divide them by what we have. I know that in games where the random variable is points or money awarded, the expectation of a fair game is 0. And so what we actually look at usually is we play games that like we win money or we lose money, or we win points and lose points. And if the expected value is 0, then it's a fair game. So you imagine a fair game is like flipping a coin. I win if it's heads, you win if it's tails. The expected value, if +1 is a win and -1 is a loss, the expected value is 0. Uniform distribution, don't love this probability. I mean, it's really just kind of common sense, but it's just 1 divided by the number of terms. So we saw all those cases, each probability is just 1 out of that. Where n is the number of outcomes. Example, very simple, rolling a die, you got 6 outcomes, each with probability 1/6. A fair game was when the expected outcome for a game is 0, and we just break even. So we got a game here. Is a die is rolled. The prizes are given depending on what the roll is according to the table. if the game costs $4 to play, what should the prize be for rolling a 4 if the game needs to be fair? So these are the prizes. The game costs $4, and we just want to find out how can we figure out what this question mark should be. Probability of each one is 1/6 because it's just the probability. Notice that the X is not the roll. It's not 1, 2, 3, 4, 5, 6. It's actually the money that you would win. The expected value, we've got X times P of X, so just 5 sixes, 0 over 6, 2 out of 6. We call X out of 6 because we don't know. Just each one is being multiplied by 1/6. 3 out of 6, 10 out of 6. The expected value, the total is X plus 20 over 6. We keep it like this all out of 6 just so that we already have a common denominator. We have fractions here, but so we're just going to add up the numerators and then divide them by 6. This is a helpful way to do it if, I mean, you could use decimals, but like it just keeps it all exact values. So the expected value is X plus 20 over 6 minus the $4 that it costs to play the game. So you're already like losing $4 for sure. And then your expected value is X plus 20 over 6. Now this minus 4 is just to kind of, I mean, the expected value we usually say is the sum of X times P of X, but it's just like to compare it to the minus 4. You can put 4 as an outcome to each one of them, so really winning $5 is only winning $1, winning $0 is losing 4, winning 2 is losing 2, and so on. Since the cost to play the game is $4, and since we want a fair game, we're gonna like try to solve this equation for X. So we want to find out when does this equal 0. So put the 4 on the other side, multiply both sides by 6, subtract 20 from both sides, and we get X equals 4 again. So this prize here should be $4. And that way it would, and if you think about it, would be here is 4 plus 20 would be 24, divided by 6 would be $4. And that's what it is for the game to be fair. Win $4 and lose $4. Okay, just practice now. So there's actually 2 your turns on page 156, so you're asked to be doing the one from example 2. Okay.